In this video, I'm going to show you how to rationalize the denominator when you have a binomial in the denominator. So we're going to use something we call conjugates. And a conjugate is when you take the binomial and you just change the sign in the middle term. So I'm going to multiply by 2 plus the square root of 3 and then 2 plus the square root of 3. So literally the same concept is I'm multiplying by 1. This is just worth 1. I don't change anything. I change the numerator to the denominator, but I'm creating a perfect square so that there's no radical in the denominator. Remember, that's not allowed. All right, let me show you how that works. I'm going to put parentheses around all of those, and in my numerator I'm going to do distribution. 7 times 2 is 14, and 7 times root 3 is going to be plus 7 root 3. All right, and in the denominator, if you remember the difference of two squares, you had a little shortcut. It was foiling first, outside, inside, last. And this is the reason we want to remember how to do this quickly, because it makes these problems so quick. The first terms are 2 times 2. Those first terms were 4. The outside terms were 2 root 3, and the inside terms were 2 negative 2 root 3. Those were opposites, so they would disappear. And then the last ones was going to be root 3 times root 3, which would be root 9, so that's negative root 9. And negative root 9 is now perfect because I created it to happen, and that's 3. So 4 minus 3 is 1. My denominator would be a 1. And I know I really don't need to write a 1 up under that. There's nothing else I can really do to this problem, so the answer is simply 14 plus 7 root 3. Let's do one more like that. Let's do root 13 over the square root of 5 minus 2. All right, I know since it's a binomial, I'm going to have to use the conjugate, and that just means take the denominator, write root 5 plus 2 over root 5 plus 2. So I need it in the numerator and the denominator. The conjugate is changing the signs. Put yourself parentheses around everything, and then start distribution. Okay, 13 times 5 under the radical sign would be 65, root 65. And then 2 times root 13 will be 2 root 13. And there's nothing that goes into 65 and 13 from our perfect square list, so they're done. There's nothing else to do to that problem. And then for the bottom, we've created a difference of 2 squares, so I'll take the first terms and I get the square root of 25. Square root of 25 is 5. And then I take the last terms and multiply those. Negative 2 times 2 is negative 4, and 5 minus 4 is 1. Now that's not always going to happen, where there would be a 1 right here. That won't always happen. It just has on these two problems here. Remember on this, the outside and the inside terms were opposites, so that they disappeared.